So the way that I've been attaching these conductive threads to the system is I've been starting out by tying a knot in the thread. And I'll probably do it right about there. Do it here as well. And then I'm going to connect a DuPont connector to it, but I'm not going to put the plastic cover on it. So the DuPont connector is like what's on the end of these, and I have the parts to be able to make my own. But instead of doing, like I said, no plastic, black plastic part on the outside, I'm just doing the metal interior. Break off one of these. And then I'm going to use this and crimp this onto the thread. It makes a really nice, tight connection. And let's see if I can remember how I did this last time. Okay, it's a little bit difficult to show doing the process on video, but this is what you get. You get that little connector on the end. I'm going to try and do it on video. It's a little tricky. Get another one off of here. Basically, I've got to keep the thread trapped in the channel here. There we go. Alright. It's kind of tricky, but there they are on the ends. And I'll trim off that extra thread after the knot. And that's a pretty decent connection for these tests. There. So, when I want to plug into these will just lock right in. They have a really nice tight hold. Good connection. And I'll use this to connect all 4 of these to the capacitive touch board. So I'm going to finish putting the other 2 on, and then we're going to jump over and solder up the capacitive touch board. So I decided instead of soldering up a new capacitive touch board, I would just go with the existing one. I think all the code is going to be able to handle it. I just unplugged the old one, plugged the new one in. I got the first 4 connections from 0 to 3. I got that all set up. Just waiting for the pie to warm up here, and got the serial plotter up now. I'm not sure which is which yet. It looks like it's going to be these bottom 4. That's what I'm thinking. These ones down here. I think these are unused, and these are the ones that are going to react. So we're going to try with the first one. This is number 1. There we go. We got a nice blue spike there. Now we're going to go to the second one, which should be red, I think, according to the way it was before. Yep. There we go. We got a spike on red. Now we're going to try the horizontal ones. The top one first. That should be the 3rd channel. And we get, what do we get? A green spike. Nice. Nice. Exactly what I was hoping for. Now the final one, the 4th one, we should get a yellow spike. What's that? There it is. So I worked with Claude for hours and hours trying to debug this graphic display for the new 4x4 grid synthetic skin. And honestly, we've got grids, but I haven't even touched anything and it's already lighting up. Touching the B quadrant, see what's happening. Yeah. Okay, so it's been about an hour or two more, and I think we got somewhere close, and then I started going over Claude's thresholds in the code, and I changed those according to what I was witnessing. We have some live 4 values for each of the electrodes, and I was just watching them change, stay in their default, and what they change to when they're pressed. And I started playing with the numbers up here, so the at rest and the being depressed settings, and I think I finally tweaked it. So got the A, B, C, and D. Where's my D? There it is. Okay. A, B, C, and D. There we go. All right. So there's the 4 grid, and that was the display showing up. These are the running values. So while this, you know, is a real simple display, I think it shows the capabilities of this, although I think when I move into the future, I'm going to be moving away from that stainless steel conductive thread and switching to an elastic type. So I'm going to be looking for that, and that will probably be the next incarnation of the skin. So I think we've reached the end with the stainless steel. But success. All right, until next time.